Hey friends, and welcome back, and this time I will be proving the product rule. The product rule is the derivative rule that I introduced to you in last video, so if you haven't seen that video, watch it first so you know what the product rule is, and then we can prove it. So this is for you that are interested in further developing your understanding of the rule and knowing where it really comes from, and therefore really understanding it even deeper. So first, let's just refresh our minds. What is the product rule? Again, if you're not really familiar with what it is, I would highly recommend watching my previous video before this one. But basically what the product rule claims is that if you have a function that is made up of two other functions getting multiplied by each other, then the derivative of said function will be the first part of the function, its derivative times the second part, and then plus the first part of the function times the second part, but its derivative. So again, if you're not that familiar with this, I would recommend going and watching my first video and then coming back to this right after. So for example, a function that we would apply the product rule to would be if h of x is equal to ln x times e to the power of x. This would be our f of x, and this would be our g of x. Another example would be if h of x is equal to e of x times 3x plus 5. Again, this would be our f of x, e of x would be our f of x, and our g of x would be 3x plus 5. Now let's get to proving this rule right here. So in order to prove the product rule, we'll have to come back to our definition of derivatives in the first place. And if we remember how we define derivatives, we define derivatives as the limit as delta x approaches 0 of h of x plus delta x minus h of x over delta x, again, this right here. And this simply comes from the fact that the derivative is the slope at a given time. So if we have 2 points on a function, let's say x and then x plus delta x, then as these two become closer and closer, we move closer and closer, then this right here is going to be our instantaneous slope, which is what our derivative is. So now that we have refreshed our minds and we recognize that this is the definition of the derivative for our function h of x, let's rewrite it as we have in terms of g of x and f of x. So h prime of x is going to therefore be the limit as delta x approaches 0 of f of x plus delta x times g of x plus delta x minus f of x times g of x, again, all of that over delta x. And this is just us using this definition of h of x instead of simply writing h of x. Now, to go from here, this is the step that is the most unintuitive about this proof, because really this proof is really simple. It's just that this one step is kind of confusing. So we rewrite this whole limit as the limit as delta x approaches 0 of, and then we rewrite what we had previously, except in the middle right here, we're going to add a part which might seem kind of random, but this part helps us factorize this limit out, which then gets us to our final proof. So we're going to have minus f of x times g of x plus delta x, and then plus f of x times g of x plus delta x. And this again, just making sure that we understand, this ends up being 0, so we're not really adding or subtracting anything, so the expression is still the same. And then don't forget the minus f of x and g of x that we have from here. Once again, everything over delta x, right? So this is just this expression right here, except we have added this middle part, but this middle part is equal to 0, so it doesn't actually change the fraction at all. Now we factorize this. For this part right here, we can factorize the g of x plus delta x. And for this part right here, we can factorize out f of x. So what do we end up with? We end up with the limit as delta x approaches 0 of f of x plus delta x minus f of x times g of x plus delta x, and then plus f of x times g of x plus delta x minus g of x. All of that over delta x. Now I'm just carrying over to the next page. Now this, we know based on the rules of limits and how we treat limits, we can write this as two separate parts. So we can write this as the limit as delta x approaches 0 of f of x plus delta x minus f of x, all of that times g of x plus delta x over delta x, and then plus the limit of the other part, which is the limit as delta x approaches 0 of f of x times g of x plus delta x minus g of x. Again, all of that over delta x. So all we have done is we have separated these two expressions right here. Now, if we also remember how we can treat limits, we know that we can treat limits if we have two limits that are getting multiplied by each other, or if we have two parts of a limit that are getting multiplied by each other, we can rewrite this as the limit as delta x approaches 0 of our first part, which is f of x plus delta x minus f of x, all of that over delta x, times the limit as delta x approaches 0 of g of x plus delta x plus the limit as delta x approaches 0 of f of x times the limit as delta x approaches 0 of g of x plus delta x minus g of x over delta x. And again, we can do this because if we remember, if we have the limit of, for example, x approaches a of ab, then this is equal to the limit of x approaches a of a times the limit as x approaches a of b, right? And in this case, for example, one of our variables is this fraction right here, and the other one is the g of x plus delta x. So we have separated this, right? This and this like this. This is why we don't have the delta x in the denominator right here. That's the reason, because this is one fraction and this is the other. And in this case, we have this as our first multiplier, and this is a second fraction in and of itself. Right, so let's carry on. We're almost there, I promise. So now, what is the limit as delta x approaches 0 of g of x plus delta x? Well, that's just going to be g of x. As delta x approaches 0, you're going to simply end up with g of x. So we can write this part as g of x times the limit as delta x approaches 0 of f of x plus delta x minus f of x, all of that over delta x. And then what do we do with the second part? Well, what is the limit as delta x approaches 0 of f of x? Well, that doesn't even involve delta x, so we can simply write this as f of x, because as delta x approaches 0, there is no impact on this of f of x, so we can simply write this as f of x times the limit as delta x approaches 0 of g of x plus delta x minus g of x, all of that over delta x, right? And if you look at this, do you recognize something? If you look at these two parts right here, these two limits, what do they remind you of? Well, if you look back to how we first defined h of x, this is exactly the definition of a derivative. So these two parts right here, these two limits, are the derivatives of, in this case, f of x and the derivative of g of x. So we can simply write this as g of x times f prime of x, so the derivative of f of x, plus f of x times g prime of x, so the derivative of g of x. Again, because this is simply the limit definition of g of x. And that is our proof. So this is equal to h prime of x. So this is our final answer, and these are all the steps we have taken to get there. The most confusing step, I would say, is this one right here, where we add this middle part that equates to 0, but the only reason we do this is so that we can factorize from where we then simplify to simply recognize that in the end we end up with one function times the limit definition of the derivative of the other one. So I hope you enjoyed. I hope you understand where the product rule comes from and are a bit more convinced by it, so to speak, because never trust something where you haven't seen the proof. So I hope you enjoyed, and see you next time.